Silicon Saxony, Europe's largest semiconductor cluster and home to a new TSMC-backed fab, is at the center of the EU's chip ambitions. Instead of trying to play catch-up with Taiwan, though, the German model is banking on developing the technologies that will define the future of the industry. We're speaking to one of the key players spearheading research in advanced packaging, chiplets, and 3D integration that will shape the next generation of AI and high-performance computing. Dr. Manuela Junghähnel heads the wafer-level system integration at Fraunhofer IZM's ASSID Research Center in Dresden. Can you explain what makes this cluster unique?
Yeah, thank you very much. Free State of Saxony, this is the heart of microelectronics here in Europe, where the first microelectronic components were invented more than 70 years ago. And after the reunion in Germany, this area where we are is developed to, let's say, the heart of microelectronics. A lot of big global players for semiconductor industry are located here. Our direct neighbor is Global Foundries, but we are also close to Bosch, to Infineon, to X-FAB, and the new facility from ESMC will also set up here in our neighbor region. Fraunhofer IZM founded 15 years ago in the former location from Qimonda, which was developing chips for memories. Fraunhofer took the chance to hook over this facility here, invested 50 million euros, the main place for 300 millimeter heterogeneous integration. That means advanced packaging. At that time, it was visionary, and today we are directly in the heart. The decision to work on this 300 millimeter wafer format at this industrial level, so everything what we are doing is close related to industry. Fraunhofer itself, founded more than 70 years ago with the aim to support industry with research and development. We have more than 70 institutes for several or different technology developments. Together with the other, let's say, RTOs we have here in Europe, with IMEC, with LADI, but also with VTT and other institutions, we are strongly connected to support the semiconductor ecosystem here in Europe from the research side. A little bit comparable, I would say, what you have in Taiwan. I had the chance last year in September, October, to visit with the Prime Minister of the Free State of Saxony, TSMC, ITRI, and other companies in Taiwan. And when I was in Hsinchu, I saw also that you have a comparable ecosystem and environment like we have in Saxony. It's a little bit comparable, I would say.
What's interesting, though, about how you're approaching the semiconductor industry, advanced packaging and system integration, can you explain how that works into EU's semiconductor strategy?
What we are doing here at ASSET, we are working on wafer-level system integration. That means we are not manufacture any chips. We're taking the chips, we're putting this in a system in 3D, for instance, stacking step chips over and over to have a very compact device in the end. And we call this what we deliver for further suppliers, we call system in packages. And we have here in-house for 200 and 300 millimeter wafers a full process line to do this. This means we have technologies like lithography, like wet chemical processes, like PVD, and also singulation, thinning of wafers. We have all these processes available, and it is a kind of a toolbox to provide in the end for the customer the right system.
So, the narrative we hear in this part is, how small can you get your chips? Going from, we're now down at 2 nanometers, but there is a point where it can't get smaller than that. And I believe this is where, advanced packaging and systems integration and chiplets come in. Can you explain how this leads to the next generation of AI and computing?
Yeah, of course. There is a huge demand to shrink in structure. So, maybe Moore's law say that every 2 years, the structure features will decrease to double also memory. What for that need is, we have to shrink in, we call this RDL, redistribution layers, have small electrical contact lines to be more compact, to make smaller devices. The demand of memories chips is very, very high. We think about wafer scale engines and so on, and for that we need a special integration technology, and that is what we are providing. And for that we need special equipment which allows us to shrink in the structure features, for instance. Another very important thing is that all these applications for high performance computing or edge AI and so on are very powerful. They have a lot of power consumption. And that means we need also technologies which reduce this power consumption and also allows thermal management inside the device that they not heat up so much. And that is also things we are targeting in our research field.
Yeah, and you have collaboration within the multiple institutes that are working within Silicon Saxony, I believe. How does that work?
So the Silicon Saxony has more than 600 participants, not only in the Saxony region, nowadays also Europe-wide. And we have very good collaborations with the CEA Leti in Grenoble. Here we are working in that famous pilot line together. We have very good collaborations with the IMEC. And of course, we have also cooperations with ITRI in Taiwan. I visited last year. They will set up also at the moment, it is ongoing, it's an ongoing process at the moment, they will set up also 300 millimeter technologies for advanced packaging. And here we see a lot of connection points for cooperation, also to provide directly in Taiwan our R&D service together with ITRI, for instance.
From a research perspective and a R&D development perspective, from an ecosystem perspective, what do you believe Taiwan's semiconductor industry can benefit from the work that you're doing or the research that's coming out of Silicon Saxony?
We are not only doing developments for Silicon Saxony, let's say, we are doing these developments for partners over the whole world, and Taiwan is here a big partner for us. So ITRI and as well Fraunhofer, we are starting on a relatively high technological readiness level, so maybe 4 or 5, and before we transfer, then we scale up. We are doing yield improvement and all that stuff. So we are also in preparation to do technology transfer, and that is comparable, and that's why it makes sense from our side to work here in this field together.
I want to step back and take a bigger picture look again. The EU has a very ambitious goal with the EU Chips Act to reach 20% of global semiconductor production by 2030. From where you're standing right now, how realistic is that goal?
That's a very good question. We have to keep in mind also that the general demand on computer chips will increase. So when we look about applications like in automotive or in other fields, we see really a growth of demand of different chips in this. And that is a race what we are doing at the same time. On one hand side, we are working to increase capacity here in Europe. So that is what is ongoing at the moment. ESMC is coming, also Infineon expand their facility. Also Bosch is here, especially in Dresden, and it will expand too. Global Foundry is expanding, and this is also all oriented to fit this demand on higher number of computer chips. But I cannot really say at the moment, can we win the race and provide really in the end that 20% of the world market? We will see in the end.
Yeah, hard to tell, isn't it? Because like you said, the chip demand is just going to keep growing. As you want to start supplying more of that demand, that means you also need a bigger workforce. So how strong would you say is the talent pipeline in Dresden? What would you say are the biggest recruitment challenges? As I know in Taiwan, there are also a number of challenges in this field.
When we think here in the Dresden ecosystem, at the moment, 81,000 people are working in the semiconductor ecosystem. The plant from ESMC needed additional 2,000 highly educated people, engineers, not scientists, also scientists and technicians in the broad field. So, and so in Saxony, on the certain level of education, we have activities here, and there's a big exchange program with Taiwan and the technical university here, which allows that students from Germany come to Taiwan directly to TSMC for 6 months and learn directly what is needed in the job. Also that is a high specialized and specific education what is ongoing here. And on the other hand side, also students from Taiwan come here because we are waiting also for employees from Taiwan here in Germany to fulfill this demand on employees we will have in the future.
Are you finding more people or more young people going into this field?
From my point of view, I would say it's difficult because when I look to the young people here in Germany, the choice to study semiconductor technologies is not only the first choice. It is not the same as you promoted in Taiwan. Let's say.
When it comes to Taiwan's semiconductor success, its work culture has a lot to do with it. You always hear about semiconductor companies saying that their big advantage is the workforce is very happy to do overtime. They're incredibly committed to the job before anything else. And I was wondering, is there that same work culture that you're seeing in Dresden? And how much of that work culture is expected there for the semiconductor industry to thrive?
I would say in Germany it's really different from Taiwan, I would say. So we are working very hard, but we have also regulations. And when I talked last time with Christian Koch from ESMC, he told me that one of the biggest challenges is for Taiwanese people learn here the German culture, how we are working here. So we have really limitations. We have unions here. We have regulations. That's a huge difference between Taiwan and Germany. And that has to be overcome. I love working. I work very long, but I don't expect it for my staff or so. But in general, if it is needed and if we have strong, let's say, to reach delivery dates or something, then we can also do hard work, let's say, over the usual time, which is negotiated with us. Yeah.
With TSMC's expansion in Dresden, there's likely to be an influx of talent. So what's your advice to those relocating to Germany, particularly those who are coming from Taiwan?
I would say living in Dresden is very easy. It's a very nice town in general. So we have a broad cultural mix here. Because we are a university town, it's also a town where a lot of young people are living. So I think it is attractive also for Taiwanese people. I think a lot of the citizens from Dresden don't know so much about Taiwan, but they are in general people which are very open for new culture and so on.
And finally, and this really is my final question, seeing that you're at the forefront of research, particularly when it comes to semiconductors, if there's one thing that we all should be looking out as far as in advancing semiconductors, what would it be?
From my point of view, what is underlighted here in Europe, it's advanced packaging in general. So we have a lot of this chip manufacturers here in Europe. But when we think really about advanced packaging, there's only one company, that is Amkor. As I mentioned, we have partners in Taiwan for this already. And if we have tasks for this, then we also in contact with them and talking about this. So, but when I look in advanced packaging, what we have here in Europe, it is a little bit poor. And here would be my wish also that the industry enhance for that advanced packaging, also the activities here in Europe.